Hello and good morning. Let's talk about week 3, quarter 2. And before we get started, if you see your initials here, these are the students I have slated so far for taking the hard copy test in class on Friday. The rest of you will be testing from Friday to Monday. So keep that in mind. Okay, so if you didn't turn your work in on time and you had to email it to me, that's pretty much the same thing as turning in a hard copy, okay? So let's keep moving. If you need to talk to me, come talk to me after class or after school. Okay, so let's take a look. Find an ink pen. All right, so here we go. So if you take a look, what are the 4 ways to prove triangles congruent? Number 1 is side, side, side. Number 2 is side, angle, side. Then angle, side, angle. And then angle, angle, side. Those are the 4 ways. For a right triangle, you have 3 additional ones. Hypotenuse leg, 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 and leg angle. Okay, you got to memorize those. And this is for a right triangle. Okay? And remember, the hypotenuse is not the L. So if you color the L, your hypotenuse is the one that's not colored, just so you know. All right, let's keep moving. We did 1 and 2. Number 3, it says, is triangle number 1 congruent to triangle number 2? Well, let's see. If this is 90 degrees and this line is 180, then that would make this one 90 degrees because it's got to add up to 180. So they're both right angles and right triangles, and this one is reflexive. So if you look at the 2 triangles, if you separate them, they overlap here. So that is reflexive property. Therefore, they're equal. Okay? And this is your hypotenuse, and it's equal to that one. So you have hypotenuse leg, hypotenuse leg. So yes, triangles congruent by hypotenuse leg. All right, it's a good idea to separate the triangles if they're touching each other, and that's what we're going to focus on today, is separating triangles. All right, let's move on. On a new sheet of paper, copy down everything you see right here. All right, now let's take a look. It says step number 1, you got to separate the triangles, and are the triangles congruent? What are corresponding sides and corresponding angles? Well, let's take a look at this first. If you take a look at this, you can match up the sides and the angles because that's the key. So put key and put FHJ is, well, we don't know they're congruent yet, and KHG. We're going to assume they are congruent. Okay. So FH is the first 2. So you're going to put the first 2 over the first 2. So the sides, and you need to know this, in the angles. So the sides would be FH would be congruent to KH. And these are segments. The second 2 would be HJ, and the second 2 would be HG. Congruent. And then finally the first and last, FJ, would be congruent to the first and last, which is KG. Make sure you know that, okay? Those are the corresponding parts, and I need to make this a little bit smaller. Okay, so let's take a look. Now let's do the angles. The angles are going to be real easy. It's just the first one and the first one. So angle F would be congruent to angle K, all right? H would be, of course, congruent to itself, and J would be congruent to angle G. And those are the corresponding sides and angles, but first, you have to really prove that the triangles are congruent. So let's do that right now. So right now, I want you to separate these 2 triangles. Okay, you got one that looks like that, which is going to be FHJ, And then you got this other one here, which is going to be this one here that I'm highlighting right now. That one would look like this, and that one would be GHK. So there it is right there. I got them separated. So on your work today, step one is to separate the triangles. Okay, so let's keep moving. Now that we have them separated, we need to prove that they're congruent. Okay, so notice that this one has 2 marks, this one has 1 mark. So if you add up the 2 marks and the 1 mark, you get the whole thing. So in other words, if the 2 mark was 9 and the 1 mark was 2, then the whole thing would be 11. On this other triangle right here, this one's got 2 marks and 1 mark, so that would be 9 plus 2. This one would be 11. So those sides would be equal, and that would be segment addition postulate. Write that down. Segment addition postulate. That's on the EOC. So make sure you know that. When you add up pieces, like that segment plus that segment to get the whole thing, that's called segment addition postulate. You need to know that. All right, so let's keep moving. They both have angle H, so you can mark that one. You see how H is at the top? They overlap there. And let's see what else we can do here. See if there's anything else we can say. So, okay, we got the angle. We got that side. And let me see what else. Okay, I'm not seeing anything else. So for the time being, we're going to leave it just like that. All right, because they didn't really ask us to prove that the triangles were congruent, although you should be able to. And I'm not seeing the third thing, but we'll leave it like that. So let's go on to example 2, where we're actually going to prove and have enough information. Okay, that one I'm not sure we had enough information. But we gave it a good try. Let's take a look at this one. Copy that down. Okay, step 1 is to separate the triangles. So here, you got this triangle right here. Okay, and let's see, they got to give us something else, and I know they did. So let me look back at the book real quick and see what else they gave me that I didn't mark down. All right, so write this down as well. They tell us that this piece is equal to this piece, and this bottom piece here, or this whole thing from here to here, is equal to this whole thing from here to here. Okay, so that's the information we got to add there. I knew there was something else. All right, so let's keep moving. Step 1 is separate the triangles. So you got one triangle that looks like this. Then you got another triangle that looks like this. So separate them like that. Okay. Now this one would be VWZ. This one over here would be, let's see, V, Y, and Z. Okay, so step 1 is complete. I separated the triangles. Now listen to my reasoning here. Both of these triangles have WZ. See how, or VZ. See how this one has VZ and this one has VZ? That's congruent to itself. That's called reflexive. That's the reason. Okay? Also, let's see what else they give us. They tell us, now watch this carefully, all right? They tell us that this big one, let's say the big one is 10, and this little one, let's say, is 3. So 10 minus 3 would give me this bottom one right here, from here to here, which would be this one over here, which would be 7. Okay, now watch over here. If this big one is also 10, because they're equal, and this one were 3, then this bottom one here would be 7. So basically what I'm trying to tell you is these bottoms are equal. And that's called segment. We're actually subtracting segments here. Okay? So now we have that. And we need one more thing. Let me see what else they give us. Okay, so we can also get the bigger angle. Or they gave it to us. So this big angle right here is equal to this big angle. Well, that big angle is this one. And it's equal to this one over here. So now we have the triangles congruent by angle, side, angle. So now we proved that the triangles were congruent. Took us a little work there, but we got it. And it says, what triangles are congruent? Well, it depends how you name it now. You could name it VWZ, so triangle VWZ is congruent. Now notice it's going from one mark, no mark, and then over here. Okay, so one mark, no mark, and then over here would be ZYV. ZYV. You have to name it however you name the first one is the same pattern you have to name the second one. All right, the last one. Is this segment, VW, congruent to this segment over here? And the answer is yes, because, so number 3 is congruent because corresponding sides of congruent triangles are congruent. Write that down. Corresponding sides of congruent triangles are congruent. So, what did we do? We separated the two triangles, step 1. Step 2, we proved that the triangles were congruent by angle, side, angle. And then finally, their parts are congruent because the triangles are congruent. See, VW is the first two, and that would correspond to ZY, which is the first two. Notice the pattern is the same. All right, so today, here's your work. You're going to separate the triangles and then work it out. Now let's take a look here. That took me a little bit of time to do, and I'll work some of these first ones here to get you started. So let's take a look. Number 1, what are the corresponding sides and the corresponding angles? Well, you're going to put sides and angles for number 1, and you're going to go first two, second two, first and last, and then do the angles. This one right here, what are the common parts of the triangles? You got to separate the triangles. We actually did that one just a moment ago. So today, you're going to start working on this page, page 194, and work all the way to the end. What theorems can be used to prove overlapping triangles are congruent? All of them. All 7 of them. Side, 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 hypotenuse, leg, all 7 of them that we did on the bell work. Number 2, construct an argument to prove these. Okay, now this is not actually a proof, so I want you to do it. You're going to separate the two triangles. One of them looks like that, and then the other one looks like that, and then you're going to label it, and then you're going to say how they're congruent. In other words, this one's got the same markings, this one's got the same markings, so this would be equal to that. Okay, they both overlap at this upper angle, so you would say they have that upper angle in common. Also, this angle here would be this one here, and that angle would be that one. So these triangles are congruent. So triangles congruent by angle, angle, side. Angle, angle, side. And that is the argument you would use. Okay, so yes, do that one. Error analysis. I want you to try it even though it says proof. Okay, find out what you did wrong. Separate the two triangles. All right, we're going to turn our attention now to MCR. And to do MCR, we're going to look at the bell work. Okay, so MCR is right here. Let's take a look. Now, before we get started, we have a test coming up this week, and if your name is on this list, these are kids that either turned it in via email from their parent, or some of them were hard copy, but I consider both of them to be a hard copy. So if your name's on this list, you will be taking a hard copy test. If you have a question, come see me after class or at the end of the day, and we'll talk about it. All right, so let's keep moving. Let's work these right here. All right, so this is going to be 2 times 2, that's going to be 4. And here you got the same base, so you're going to add those up. So it's going to be 4m to the 5th power. This one you're going to knock everything down, so it's going to be 2 to the 4th and x to the 8th. And 2 to the 4th, 2 times 2 is 4, 4 times 2 is 8. I think that's 16 x to the 8th power. This one, both of these are going to be dropped down. In fact, it's the same exact problem. Okay? So you can say same thing. All right. On a new sheet of paper, copy all of that down. We're going to talk about scientific notation. Scientific notation is a number between 0 and 10 and a product of 10. If you have a bigger number, it will be a positive exponent. A smaller number will be a negative exponent. So look here. If you take this number, you ask, where is the decimal? The decimal, if you don't see it, is right here in the back. So the question is, how do you get this between 1 and 10, or between 0 and 10? Well, you're going to move it 1, 2, 3, 4, 5, 6, 7, 8. So you're going to get 1.5, which is between 0 and 10, times 10 to how many places you moved it? 2, 4, 6, 8. You moved it 8 places. And it's a positive because the number's bigger than 1. Watch the next one. The next one right here is smaller than 1. So you're going to take this decimal and move it all the way to here. So you're going to say 1.5, always one number in front. So it's times 10 to the 3, 6, 7, 8. And that's a negative because it's less than 1. Point all of those zeros is less than 1, so it's a negative. All right, look at the next one. The next one right here, you're going to move your decimal to the right because it's a positive 3 places. Here's your decimal if you don't see it. So 1, 2, 3 is going to be 25,000. Real simple. And then this one's less than, so this is a positive 3. So you're going to move it to the right 3 places. And I think I meant to put a negative. So put a negative there. In that case, you're going to move it to the left 3 places, so it's going to be 0.00025. And there it is, and that's how you do it. And I want you to look at example 2b and example 3 on your own, and here's your work for today. Have a good morning.